Hello, my name is Mike Gonzalez. I'd like to present a basic understanding of the TCP/IP protocol and how data travels through the TCP/IP model as compared to the OSI model. So, what is TCP/IP? TCP/IP is a suite of networking protocols that allows devices to communicate over the internet and other networks. Basically, it's a set of rules that governs how data is transmitted, routed, and received. To break up the two main pieces, TCP is the component that collects and reassembles the packets of data. IP is responsible for making sure the packets are sent to the right destination. You might think of it as the language that computers use to talk to each other. How did the protocol begin? The TCP/IP protocol suite was designed in the 1960s by the U.S. Department of Defense and was further developed in the 1970s by two DARPA scientists, Vint Cerf and Bob Kahn, persons often called the fathers of the Internet. In the early versions of this technology, there was only one core protocol, which was named TCP. And in fact, these letters didn't even stand for what they do today. Instead, it stood for Transmission Control Program. During the development of TCP, Cerf and Kahn used the concepts of Cyclad, a French packet switching network designed and directed in 1973 by Louis Pizon. It was developed to explore alternatives to the ARPANET design to support network research generally. Cyclad was the first network to make the host responsible for the reliable delivery of data, rather than the network itself, using unreliable datagrams. In fact, Pizon actually coined the term datagram by combining the words data and telegram. TCP/IP was fully developed in 1983 and became the protocol standard for ARPANET, the predecessor to the Internet. The layers of TCP/IP. When a data packet travels through the TCP/IP model, it passes through 4 layers, each with specific functions before reaching its destination. The application layer is where the applications operate, for example, web browsers and email clients. Here you'll find the protocols HTTP, SMTP, DNS, and FTP. The transport layer ensures reliable data transmission between applications. TCP and UDP are the main protocols utilized. At the network layer, also known as the Internet layer, it handles the addressing and routing of data packets across networks using the Internet Protocol, or IP. At the network interface layer, also known as the link layer, it deals with the physical transmission of data over the underlying network mediums such as Ethernet, Wi-Fi, and Bluetooth. Now let's look at how it moves through each layer. At the application layer, the process begins where the user interacts with the network service, such as sending an email or browsing a website or just transferring a file. As mentioned on the previous slide, protocols such as HTTP, FTP, SMTP, and DNS all operate here. HTTP is the Hypertext Transfer Protocol, which is used for web browsing. SMTP is Simple Mail Transfer Protocol that's used for sending emails. DNS is the Domain Name System. It translates domain names, such as google.com, into IP addresses. FTP is the File Transfer Protocol, used for transferring files between computers. Here the data is formatted into a message and passed to the transport layer. The transport layer is responsible for reliable data transmission and flow control. The two primary protocols are TCP and UDP. TCP, or Transmission Control Protocol, ensures the reliable ordered delivery of data by breaking it into segments and adding sequence numbers. UDP, or the User Datagram Protocol, provides faster but unreliable transmission, typically used for streaming or voice over IP. Each segment is labeled with the source port and destination port, then sent to the network layer. The network layer, also known as the internet layer, is responsible for routing the data across the network. Here is where you find the Internet Protocol, or IP for short. The segment from the transport layer is encapsulated in a packet, and an IP header is added. It contains the source IP address or the sender's IP. It'll have the destination IP address, which is the receiver's IP, and it includes other routing information. The packet is then forwarded to the network access layer. At the network access layer, or the link layer, the packet is encapsulated into a frame with the media access control, or MAC addresses, and the error checking data. The frame is converted into electrical, radio, or optical signals and sent over the network medium. For example, Ethernet, Wi-Fi, Bluetooth. To summarize, we'll put it all together. This is how your data moves from point A to B. The process begins at the application layer, where the user interacts with the network service, such as sending an email, browsing a website, or transferring a file. The data is formatted into a message and passed to the transport layer. At the transport layer, each segment is labeled with a source port and destination port, then sent to the internet layer. Once at the internet layer, the segment is encapsulated into a packet and an IP header is added. The packet is then forwarded to the network access layer, or link layer. At the link layer, the packet is encapsulated into a frame and is converted into electrical, radio, or optical signals and sent over the network medium, such as Ethernet, Wi-Fi, or fiber optic. The data travels through switches and routers until it reaches its destination. Once at the destination, the process reverses, stripping away headers until the original data reaches the intended application. If you're interested in reading more, you can find additional information about the TCP/IP protocols on these websites. Thank you.